Professor Bialis here. In this video we are going to be covering the last section in Chapter 5, Section 7, which covers synthetic division and then the remainder theorem. Okay, let's start with the synthetic division part of it. Synthetic division is simply a shorthand version of long division. Now you might be thinking, well, why the heck did we spend all that time doing long division then? Okay, because synthetic division only works in certain cases. Okay, let's write that case down first. Synthetic division, I want you to only use when dividing by a binomial of the form x minus c. Now, what do I mean by x minus c? What does that really entail? You have a regular old x, no exponent on it, no coefficient besides the 1, and then you have a constant. Now, this x minus c, it could be a plus sign, but then we would adjust the signage later on. Okay, so some examples, if you have a divisor of, x plus 5, that would work. If you had x minus 2, x plus a half, x minus 7, those would all fall under synthetic division. What would not fall under synthetic division is something like x squared plus 2. That x squared takes it out of contention there. If we had a 3x plus 9, you wouldn't use it with that. We're only using it when we have a 1x in front and then a constant on the other side. Okay, now that c value is going to be very important to identify to get the problem rolling. So if we're dealing with x minus c, let's go to this one for instance. If it's x minus c, when you say x minus 2, c is 2, piece of cake. X minus c and you have x minus 7, well then c is 7. But what happens when you have something like this? Okay, we want x plus 5 to be considered as an x minus something. How do we do that? That can be thought of as x minus negative 5. Two negatives make a positive. So x minus c, and you have x minus negative 5, tells you that the c value would be negative 5. Same thing here. The c value would be negative 1/2. A good rule of thumb would be that to assign the c value as the opposite of what you see in here. Negative 7, positive 7. Positive 1/2, negative 1/2. Negative 2, positive 2. Positive 5, negative 5. And so on. Because it's always x minus the c. So take out that opposite sign. Okay? Now, let's look at synthetic division in action. Here, just as a quick review, is a problem worked out using that long division method that we saw back in Section 6. Now, how would I do the same exact problem using synthetic division? And after I lay all that out, we're going to kind of compare and contrast the two. So, again, I still have this problem here, but I'm going to use synthetic division. Let me write this out again. Okay, and then let's see how this kind of evolves. If you wanted some review on to see where all this is coming from, please go back to the Section 6 video where I in detail talk about that long division process. Okay, so I have this problem now, and I look at it and say, well, I'm dividing by x minus 3. Well, that fits the criteria for x minus c. Okay, so I'm going to say that my c value is 3. Whatever your c value is gets boxed in to start this off. Okay, so again, the c value, I'm going to box it in off to the side. After that, I'm going to list the coefficients of this polynomial that we had as our dividend. Now, those coefficients need to be written in that descending order, just like we had with long division. Okay, so I had a 2x cubed, a negative 1x squared, a negative 13x, and then a positive 1. Again, all I did was 2, negative 1, negative 13, positive 1. Notice what am I kind of ignoring? I'm ignoring all those variables, okay? Now I'm going to leave a space here for another row, and then I'm going to draw just a summation line, okay? Now I'm going to just kind of mechanically go through the process first, and then I'm going to explain why we're doing it that way. And you're going to see it's pretty much the same process we did here. So I always start by bringing this first number down. Just bring it down. Then I am going to multiply those 3 times 2 and bring it up there. Then I just do what it says. Negative 1 and then a positive 6. So negative 1 plus 6 is 5. And then I do it again. I multiply 3 times 5 is a 15. And then negative 13 plus 15 is 2. 3 times 2 is 6. 1 plus 6 is 7. So, simple as that. Drop down the first, then multiply, add, multiply, add, multiply, add. That's all there is to it. Again, multiply, add, multiply, add. Now, I don't leave it as that. I need to bring back all those exponents. Now, here's the rule. If my dividend started with a 3 or a 4, whatever it is, I always start my answer, my quotient, with 1 less than that. So if I started with an x cubed here, I start with an x squared down here. And I write my answer, 2x squared, and then I count down from there. Plus 5x to the first, plus 2 with no x, and then this last one is my remainder. And there we go. Okay? So again, I start with an x cubed, so my answer, I start with an x squared. 2, 1, 0, and then my remainder. Now notice, the answer is the same. Okay? Now why were we able to take this and squeeze it down to this? Remember, we are only doing this when we have x minus c. If I divide by something that's just x in the beginning, I know that I'm just chipping away one x at a time. That's why I started with 3, I chipped away a 2, then a 1, then nothing, then remainder. Okay? So the x's all kind of work themselves out. Rewrite this 6 in here. I don't need all of these here because again, they're going to work themselves out. Okay? Why did I just drop that 2 down? Because I know if there's just a 1 here, and I start with a 2, what am I going to be multiplying by? I'm going to multiply by a 2. If I started with a 5, 1 times 5 would give me a 5. If I started with a 17, 1 times 17 would give me a 17. So that's why I just dropped that down. After that, look what's happening. I got the 6. 6 was right here. I then carried it down to a 5. Well, again, same idea. I want a 5. What am I going to multiply by? I'm going to multiply it by a 5 to get a 5. I had a 2. I multiply by a 2 to get a 2. So all of these little intermediate pieces are just going to fall out very nicely once we get this quotient starting to be formed. Okay? So again, the basis behind this is we're taking away all the unnecessary fluff of long division that is unnecessary because we're dividing by something so nice and clean. If we had a divisor that had a number out in front here or an exponent here, we can't do this, okay? Then we have to use long division. But if we have something so nice and clean, we can shorthand it with synthetic. The reason we do this is because when you get into finding rational zeros and factoring out polynomials and so on in college algebra, we're going to have to divide maybe 10 of these in one problem. It would be nice if we had a shorthand way of doing it. Okay, so that's synthetic division. I'm going to go through a few more just to kind of dig into that, that process, but that's pretty much it. Number one, know when you can use it, and number two, know that process. Okay, so let's look at a couple more examples. Say that. Now, if I just said divide, then we either have breakup method, long division, or synthetic division. We definitely wouldn't use breakup method here. We could use long division, okay? But we're learning synthetic, let's try that. So first thing, again, I see x minus a c value. So my c value equals 2. It was x minus 2, so a negative 2. I take the opposite to a positive 2. Then I box that c value in, and then I write out the coefficients of the dividend. So that's a 3x cubed, negative 2x squared, 5x, and a 4 constant. Remember, leave a space here because you're going to be working in this area. I start by dropping this down. Then I multiply, add, multiply, add, multiply, add. So 2 times 3 is 6. Negative 2 plus 6 is 4. 2 times 4 is 8. 5 plus 8 is 13. 2 times 13 is 26. 4 plus 26 is 30. Again, 2 times 3 is 6. Negative 2 plus 6 is 4. 2 times 4 is 8. 5 plus 8 is 13. 2 times 13 is 26. 4 plus 26 is 30. And that's it. There's nothing more to it than that. Okay? Now, we need to pull it together, though. So, we had our initial problem start with an x cubed. Not this 3, this 3. X cubed. So, our answer is going to start with x squared. One less than that, because I divide one of those x's out. So I have a 3x squared, and then I count down. So x squared, x to the first, x to the 0, or just constant, and then a remainder. And I use this x minus 2. And there you have it. Okay? So, again, don't overthink the calculation. Just multiply, add. Now, in long division, we didn't add. We changed the sign and we subtracted with that. Now, why are we adding? Because when we took that c, we took the opposite sign, didn't we? So we kind of changed the sign here, which then when we distribute, changed all those signs. Okay? So again, we are changing the sign, but we do it right at the beginning so we don't have to do it again. So that's one big difference between synthetic and long division, because the long division we have to keep changing them as we go. Here you changed it once when we translated that out, and then we didn't have to do it again. Okay, let's do another one. Okay, so on this, we're going to take this x plus 1. We should recognize that as a binomial, so we could use long division, but since it's x and a constant, we could also use synthetic. Our c value here is negative 1. It's always the opposite of that value in the binomial. So I'm going to take a negative 1, and then I list out my coefficients. My coefficients are 1x to the fourth, 3x cubed, negative 5x, and a 4. Okay, so draw my line, bring down the 1, I multiply, get negative 1. 3 minus 1 is 2. I multiply, negative 1 times 2 is negative 2. I get a negative 7. Negative 1 times negative 7 is positive 7. I get an 11. Now when I pull it together, I started with x to the fourth, so my answer is going to start with x cubed. So I have a 1x cubed plus 2x squared minus 7x plus 11. Do you notice a difference here? Back here, I did x squared, x constant, and then I had that remainder, right? Do I even have a spot for a remainder here? You might say, well, there's no remainder, so that it's divided evenly. There's not even a spot for a remainder. When we did long division, and we didn't have a remainder, it always ended up being a 0 on the bottom. We should at least be able to see that there's a 0 there. So something is wrong with what we just did. Now, notice there was nothing really stopping us in this process until we got to the very end. You should always at least have a spot for a possible remainder. If there's no spot, something's wrong. And what's wrong? Notice we have x to the fourth, x cubed. There's no x squared. When we missed that in long division, we had the x's there to remind us. We don't have that here. But what we do have is a missing remainder spot. So what we should have done when we started this is write it out as 1x to the fourth, 3x cubed, 0x squared, negative 5x, and then a 4 as a constant. That now gives us one more column, therefore we're going to have room for that remainder. Okay? So you can still catch it if you make that mistake, but you're not going to catch it until the very end. So try and remember, whenever you have a missing power of x, just like with long division, make sure you put that in. Okay? So I'm going to put that summation bar there, and then go through it again. So I'm going to bring down the 1. Negative 1 times 1 is negative 1. 3 minus 1 is 2. Negative 1 times 2 is negative 2. We got a negative 2. Negative 1 and negative 2 is a positive 2. We got a negative 3. Negative 1 times negative 3 is 3. And we got a 7. Okay? Now, how does this come together? I start with an x to the fourth, so here I start with x cubed. I have a 1x cubed plus 2x squared minus 2x minus 3 with no x. And then I have a spot for my remainder. And there we go. Again, I went through it incorrectly the first time so I can show you what it looks like when you make that mistake, because it's very easy to make. Okay? You always need to have a spot for that remainder. If it divides evenly, you should end up with a 0 there, and then you just leave that last part off. Okay? Don't just say, well, there was no spot for it, so there must not be a remainder. There has to be a 0 there waiting for you. Okay? So that is synthetic division. Last thing I want to do is talk about the remainder theorem. Okay? Now, the remainder theorem is paired with synthetic division because they both rely on that C value. Now, what this is used for is to not determine, but to find what the remainder is going to be without actually going through all this division. Okay? So let's say we have this problem here. And I don't ask you, give me the quotient. I just say, what's the remainder going to be when you divide that? On a test, it would clearly say, use the remainder theorem to find the remainder. This is what I want you to do. So I'm going to rewrite this problem. And again, now we're talking about the remainder theorem. Okay? The problem is going to be worded like this. Use the remainder theorem to find the remainder when, and again, I'm going to do this problem again just so we have a side-by-side comparison. Okay? So use the remainder theorem to find the remainder when we do the division, without doing the division. Okay? So the notation that I want you to get used to seeing is this. This dividend, we're going to call P of x. This divisor, we're going to pull that same C value out that we pulled out over here. So that's going to be a negative 1. Now here's what the theorem states. When you divide this polynomial P of x by a polynomial with a C value of negative 1, okay? Now notice, guys, it has to still have that x minus c idea. You can't do this when there's like a 2 here or a 5 here. It has to be x and then plus or minus a number. The remainder is simply going to be the p, that dividend, with the c value plugged in. So all I'm going to do is to take this and I plug in, so x to the 4th plus 3x cubed minus 5x plus 4. And I'm going to plug in negative 1. That's all there is to it. Now watch how this calculates. Negative 1 to the 4th is a positive 1. Plus 3 times negative 1 cubed is a negative 1. Whoops. And then minus 5 times negative 1 plus 4. So that gives me then 1 minus 3 plus 5 plus 4. 1 minus 3 is negative 2. Negative 2 plus 5 is 3. 3 plus 4, 7. And that was the remainder I found there. That's all there is to it. Now you might be looking at that and saying, well, why are we doing that? That's not that much less work than this. And you're right, for us. But if we're dealing with a computer program that a lot of this is used with, this is a much quicker calculation for a computer to go through than all of that multiply, add, multiply, add, multiply, add. Okay? And it's a lot easier to code something like this than to code something like that. Okay? Whenever we buy something online and we pay with our credit card, they encrypt that information. A lot of that encryption is based on modular arithmetic, which is all based on finding remainders. Okay? Now, the difference is when we deal with, encrypting things, these polynomials here don't have 4 terms. They have a million terms or 100 million terms or something like that. But it's still based on that remainder idea. Okay? Now, one other thing I want you to notice is here, that 0 was very, very crucial. I didn't do that here. Because if I added that 0 term in, I would have just added 0. That's not going to help me in my calculation. It helped me here in my organization, but it's not going to help me in the calculation here. Okay? So remainder theorem simply states, take that C value, plug it in, it'll tell you the remainder. Let's look at one more. So let's say we have that. But again, it very clearly states use that remainder theorem. Okay? So what we're going to do is first identify that the C value is a positive 2. This we're thinking of as a P of x, and then we are going to plug in that 2. So I've got a 6x to the 5th minus 4x to the 4th minus 40x minus 10. And then all I do is plug in that 2. Now, if the numbers get a little out of hand, you could just pick up your calculator and plug this in. But especially with a 2, if you're trying to get better at your mental math, this is the time to practice. Okay, so let's work this out. Exponents first. 2 to the 5th. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. Minus 4 times. Again, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Let me just have that 2. There we go. Okay. 32 times 6. 30 times 6 is 180. 2 times 6 is 12. 180 plus 12 is 192. If you want, just go off to the side. That's a 12. Carry the 1. 18 plus 1, 192. Guys, a lot of people think that this is just magic, okay? But all I did was I multiplied the 1's digit and then the 10's digit. That's exactly what I did before. I took 6 times 30. 6 times 3 is 18, throw on a 0, so I got 180. And then 6 times 2 is 12. Then I added that 2, or that 12. So 180 plus 12 gave me the 192. Then minus 4 times 16, that's 64. Okay. Again, if you want to, 16 times 4, that's a 24. Carry the 2. 4 times 1 is 4, plus 2 is 6. Minus 80 minus 10. Okay. 192 minus 64. Again, if you can do that straight in your head, great. If not, don't be afraid. Go off to the side and do it. 192 minus 64. Do your borrowing. 12 minus 4 is 8. 8 minus 6 is 2. 1 minus nothing is 1. Okay, so I got 128, and then I would subtract an 80. 12 minus 8 is 4. And then I would subtract a 10, and then that gives me 38. And there you go. Okay? Don't be afraid to do this. This is how we get better. Don't just pick up the calculator because right now it's going to save me 5 seconds. Okay? So that's a good investment of your time. Carry that out. The more you do this, the more you're going to be able to do it up here. Okay? So, again, synthetic division. Make sure you fill in those missing zeros. Make sure you use the opposite sign for that C. And you're only using it when you have just a clean variable plus or minus a number. That remainder theorem is going to tell you what the remainder is. Not this whole fraction, just that numerator. And again, that's only used when you're dividing by the same type of binomial. You're taking the C value and plugging it into that dividend. That's all there is to it. Okay? So, as always, work hard. Let me know if you have any questions. And I'll see you next time.